Hi, welcome back again. Today we're going to be discussing and explaining the importance of security throughout the life cycle of AI. This comprises of the part 1.3 of the CompTIA SecAI exam objective. So today we're talking about business use cases that should align with corporate objectives. We're also talking about data collection, data preparation, model development and selection, model evaluation, deployment, validation, monitoring and maintenance, human feedback and iteration, and then the final part of the part 1.3, which is human-centric AI design principles. So let's get started. So most people don't think of security when designing or deploying AI systems. They only think of security at the end or at the presence of a security threat. When we design, write codes, or choose models, we must think security first. And that's the essence of the reason why security should be thought about throughout the life cycle of AI. Security is very expensive. Most companies have suffered breaches and lost personal information or confidential information because they designed without security in mind. We talk about first the business use case and corporate alignment. So when we say use case and corporate alignment, we want to talk about how can an organization structure their goal and then use security in mind to achieve their goal. So the first step here is that every organization must have their goal, what they want to achieve with an AI. Do you want to maximize customer success? Do you want to increase sales? Do you want to increase success, customer friendliness or whatever with AI? So you map out your strategy, your mission and your goal. And then the next thing you do, which is the second thing, is to define risk boundaries. So first is set your goals. Number two, define risk boundaries. So when we say define risk boundary, we talk about you must put a stop or must have a threshold of what risks we should expect, when we use AI. For example, if we use AI for a medical system, we should have in mind that maybe we should think about a situation or a scenario where the medical LLM leaks patient data or contains personal information. Or if we use AI, for example, to recruit people, we should think about the fact that what if the AI makes recruitment or makes hiring decisions based on color, race, or racial background. So this is the risk that we must avoid. After that, you have to check your data. Is your data just trust me? So we have to check that the data is clean, relevant, and contains the right and requisite features to use to train your model. So that's where we verify the data verification. And then sanitization here involves we must we must get rid of personal information from the training process or the training data. I'll give you an example, right? Format preserving encryption, right, is a method that can we can use to remove personal or redact or anonymize personal information from training processes or training pipelines of an AI model. So let's say it's a social security, for example, right? It contains 9-digit format, right? Before we feed or once the model sees such kind of personal information being fed into the data, it verifies it. Oh, it's going to know, oh, this is a possible social security. Or if it sees a name, it should anonymize the name. Or if it sees like credit card or 16-digit credit card, you know, format, right? Because it aligns with a particular format, right? It encrypts or it anonymizes such data being fed into the model. So this is the core essence of training data encryption or training data verification before train and deployment. So this is how we can corporately align our goals before using, deploying, or integrating an AI system. So again, to better explain what I just said, we look at the business goals and the security focus. So what is the goal of data collection, right? The goal of data collection here is trustworthiness and having an authentic data to train with, right? So the core security focus for this proper data collection method is to prevent supply chain vulnerabilities. What is a supply chain vulnerability within an AI system? This refers to a scenario where you're not the problem. Your organization or your model is not the problem. The problem here lies in the third party software, open source libraries, pre-trained models, datasets, or API that the model interacts with. Again, this has nothing to do entirely with your organization or with your model. The problem here lies with open source libraries, maybe from Hugging Face or whatever platform that hosts these models or libraries, right? Pre-trained models, we don't even know how these models were trained, or data sets, right? That may be corrupted, right? An adversary can corrupt a medical data set and force the medical data set, to become a core vulnerability or to become a supply chain vulnerability. So this is the goal of trustworthy data collection. A typical scenario where this thing happened was Samsung. Samsung banned ChatGPT among employees after sensitive code leak. So we had a situation in 2023 where employees fed in proprietary logic or proprietary code into ChatGPT. This became, a sensitive vulnerability, for the data or the data pipeline system of an AI or the business corporate alignment. Why should we invest so much in AI when we lose, our proprietary logic, or we lose customers, or we get into an attack? So the goal of the security design should match, the should match the objective, not be the enemy to the objective. We are not using AI to minimize profitability. We are actually using AI to maximize profitability and stay competitive, right? So that's why you need to have these very important, designs or checks before using, or integrating your model. The next is data preparation, right? I already mentioned format preserving encryption, which helps and checks to ensure that your model or no AI system should be trained on personal identifiable information like credit cards or social security numbers or other PIIs. So that's the essence of data preparation. Your data must be prepared and void of any form of errors or contamination. So now, how do we think about secure model development? Remember, we talked about the fact that we have to check out our data is correct and verified. And then the next thing is you have to check for your model selection. So when we want to check for model selection, in previous videos that I made, we'll talk about cloud versus local hosting. So you might decide to share responsibility of hosting your model on the cloud or locally. After this decision has been made, you can now check or intend to improve the performance of your model. Optimization means you're trying to make your model better. And by doing this, we might look into quantization and pruning as viable methods that can improve or optimize our model. But what about model security? Model security here involves the building or designing of models that are confidential, integrity filled, and available against attacks. or against AI attacks, right? It's typical examples of this prevailing large language model or AI model, attacks might involve the prompt injection, the jailbreak, and the distillation attacks. So these are attacks that actually try to compromise your AI system. And how do we explain, for example, a prompt injection attack? Let's explain a prompt injection attack, for example. So the goal of a prompt injection. So this is let's talk about the prompt injection. We have an attacker, and then we have an attacker trying to combine queries, or use random queries or well-designed queries to, target the model. So here is the model. And then the goal of the attacker is to get a response that match his or her desires, right? So this is a direct query to the model to get and follow the desires of the attacker, whether the prompt or query is, safe or unsafe, right? So this is a direct prompt injection, direct PIA, prompt injection attack. For an indirect prompt injection attack, we consider or we look at a scenario where an attacker does not directly poison or query the model, but it queries a database or an external repository containing information that the model relies on, right? So the model maybe relies on a particular source or database or GitHub repository. An attacker will query an attacker will query this model, will query this external repository, right, in order to get or obtain his desired response from the model. So this explains an indirect PIA, right? So the core difference between a direct PIA or an indirect PIA is that indirect PIAs focus mainly on external repositories or sources where the model relies on for responses and generating, responses, right? So we look at another type of attack, which is the jailbreaks. So we've talked about the prompt injection, talked about the jailbreak attack. What is a jailbreak attack? An attacker usually would have to query a model. But this model, so we say this is the model. But this model usually have guardrails, usually have like do's and don'ts, right? So let's look at let's call it this. Let's use this to illustrate a scenario. This is like the guardrails, right? So these guardrails help prevent unauthorized responses. But the attacker tries to use maybe crafted responses, storytelling, compulsion, right, to bypass these guardrails. And when he has done that successfully, what we see here is that the attacker can generate, images, text, or multimodal responses, that satisfy his desire. So the attacker will, for example, use chain of thought, right, COT, right, or three of thought, TOT, or graph of thought, GOT, right, to force the model, to tell the model, to convince the model, and jailbreak or, the guardrail that the model relies on. So here we have the model, we then return responses or output, for the attacker successfully. So this can force the 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 attacker to, generate illicit responses, illegal explanations, or even pornographic or nudity responses because of the way or the stealthy and well designed method of the jailbreak prompt. The final and most prevailing um, type of um, type of large language model attack we look into is the distillation attack. So the goal of the distillation attack here is to have a teacher model. So let's look at this as a teacher model. We have a teacher which is owned by a proprietary company or which is owned by a company, right? And then you have a student model, right? And then the goal of the attacker here is to um, query this teacher model. So the attacker will query the teacher model to obtain input and output, generate API responses, and then have the data of the generated responses, and then use this data to fine tune a smaller model using maybe LoRa fine tuning, right? Or fine tuning methods, right? To get his own student model. And the beautiful thing or the scary thing about this distillation attack is that the student model here, this student model, will have the same capability and performance or similar performance, or tries to minimize the divergence of or the ability of this teacher model and student model. So essentially, what are we saying? The student model is trying to attain the level of intelligence or the level of capability, of this teacher model. The student is trying to become like a teacher, and that's why you see very small language models, or you see models, maybe a proprietary model is released today. The next day, what you see is that a new small version, probably open source model, right, has been released that is trying to match this teacher model. This is actually very deliberate, and this is what companies use, or this is what these bad actors use to, number one, what is the intent of this kinds of attack, or this kind of the distillation attack? Number one, you know, proprietary stealing, proprietary theft. Number two, API payment bypass. Number three, um, disinformation. Because when you're stealing here, you can also put your own information. You can also put your own corrupt training data, or you can put your own information, how you want the model to be responded. So you can have a disinformed student model. This model here can be disinformed. And number four, the attacker can actually bypass safety filters that the teacher model usually had before now. So the distillation attack is growing as a very prevalent concern, especially for large language model providers. Anthropic released in February this year um, a core or a storyline of distillation attacks and how possibly we can prevent and detect them. So this leads to how to secure our model development. So we look at the attack type. Number one, prompt injection attack. How do we primarily defend against or control prompt injection attack? We look at number one, prompt firewalls. Prompt firewalls are those firewall mechanisms that can look at incoming prompt or treat every incoming prompt as suspicious, and then check them for unsafe tokens or unsafe kind of representations or context. Number two is templates. If we have a template that the model usually uses to generate responses, we can primarily defend against injection attack. Number three is spotlighting. Microsoft proposed or invented this approach. Spotlighting here is primarily for injection attacks. So if you look at this study, right, defending against prompt injection attacks with spotlighting, it was proposed by it was published by Microsoft in 2024. So what does this study actually focuses mostly on indirect prompt injection attacks. When LLM systems have access to external data sources, they are the risk of indirect permission attack. In this scenario, the user and they just talk about how their spotlighting method, their proposed spotlighting method, you know, treats unsafe tokens, as suspicious, and then we can bound, those tokens, to to um to prevent any source of generation or any source of incoming prompt that looks like an injection attack. So whenever you think of spotlighting, think about Microsoft, even in the exam, or whenever you think about indirect prompt injection attack, spotlighting method is a good way to prevent against indirect prompt injection attack. But I just categorize it here into um, direct prompt injection attack. So we look at jailbreaks. Jailbreaks, how do we prevent jailbreaks, right? We use stress tests, testing your model to see if it's going to bypass your own guardrail or safety filter, right? So that's where stress tests and improved guardrails come into play to prevent jailbreaks. For distillation methods, we have rate limiting, trusted environments, and intelligent classifier. For rate limiting, remember, the attacker wants to get at least, for example, 100,000 input output pairs here. So the attacker is continuously querying and harvesting input and output responses. So by limiting strange or spiking API requests that look suspicious, we can actually prevent or defend against distillation patterns. We also look at trusted environments, and intelligent classifiers, which can help, to detect or classify, you know, prompt distillation patterns from normal API request usage. So one thing we're going to talk about here we're going to talk about model drift. So let's say, for example, we've deployed our model, we have the prompt firewall, we have our user, querying and also getting responses from the model, and then we have a continuous monitoring method. So the goal of the continuous monitoring method here is to check and, inspect the model's usage according to desired out or the desired goal, right? And then we are checking our model and we see a model drift. What is a model drift? A model drift is a scenario where accuracy drops, where we have a drop in accuracy or performance due to real world changes. The real world is actually very, very unpredictable. It has a lot of randomness, heterogeneity, uncertainty. And so we must account for these during the model training method. So that's where we check for overfitting and underfitting, and also um, fine tune your model with relevant data, to improve its performance. And then for the model anomalies that we talked about, the proposed systems in the previous slide, we can use either iteration and patching to ensure that our model is robust against any form of attacks. So this is the essence of deploying. This is the essence of deployment and monitoring and iteration within the AI lifecycle. Another thing most people don't talk about is evaluation, evals. So once the model, this is the model, right? It generates outputs, right? Evaluation looks at the output, right? Evals look at the output of this model, and then to ensure that the evals, we check the model's response to ensure that the model is actually doing what we want it to do. So we also look at human-centric oversight. The goal of humans in the human-centric oversight, or the goal of humans within the AI lifecycle, is not to take the autonomy or the power of the AI system itself. The goal of the human oversight is to ensure accountability. because computers do not or don't have the accountability mechanisms themselves or internally. The humans in the loop or human oversight here plays an important role to ensure accountability, ethical alignment. Maybe, for example, an employment AI or employment AI system does not use racial background to screen an applicant. So this is what the human-centric oversight actually does. Also, the human-centric oversight anchors the technology around human agency, context, and safety. So this is what there are some safety methods that the that guardrails or even new guardrails cannot check or see, but the human will spot those oversight or will spot those flaws. So, what is human in the loop? This might be a question also asked in the exam. The human in the loop, talks about a scenario where the AI system is not actually much in real time. For example, I want to do something, or an agent, generates output, and then the human in the loop has some time, maybe 5 minutes, 10 minutes, 3 minutes. It's not a critical scenario, right? It's not a self-executing or self-autonomous agent, right? The human in the loop checks, for logic, bias, and safety, and approves or deny, the agent's response. We take a loan application, for example. You know, there's ample time and opportunity to review the loan application. But the human in the loop will be there to see that the model's response actually match the policies of the loan application, the logic, the bias, and the safety, and then approve the loan application or not. But for human out of but for human on the loop, right? We're looking here at you know a real-time agent that runs autonomously. So if the threshold is breached, right, the agent would uh if there's no threshold breached, the agent will grant or approve the request without any human oversight. But if the threshold is breached, right, the human on the loop will check for logic, safety, and bias before approval. So this is the core difference between human on the loop and human in the loop. So we talk about some scenario questions, within this within what we've covered so far, and as it relates to the SecAI exam. So look at this question. Feel free to also pause and have a look. Yeah. So the answer here is data poisoning, right? Data poisoning is talking about data privacy. So we always just look out for the keyword, and then you're able to answer the question. For question two, also feel free to pause the video and take a look at this question. So the keyword here again is indirect prompt injection attack. You think of Microsoft, and the answer is spotlighting. Spotlighting deals with indirect prompt injection attack. This is question three. Also feel free to pause and have a look. So the gradual decline here talks about data drift. I told you that the real world has a lot of randomness, right? There's a lot of randomness, in the real world, right? And these model drift, can also be handled by this protective mechanism. Question four. Oh, I already gave the answer beforehand. So let's review. Is an autonomous grading system is employed to assist with evaluating to ensure fairness and accuracy before any final grades are recorded. The system, which, okay, the answer is not B, the answer is C, human in the loop, because the TA has a lot of time. T has time to check, but on the loop is real time. There's no do or die about it. So the T has time, and then he can check, and review the final response. And this is question four, right? So the answer here is A, rate limiting and throttling. I'm so sorry for having to highlight this question beforehand, but this is a summary of what we've covered today. So AI It's not something you think about after you deploy the model. Within every consistent phase of your deployment, we must think about security. And today, that's why we've covered everything we've covered in this class today. Talk about secure model development. We talk about the business case and corporate alignment when we use AI. So thank you very much for watching.